Hey guys, so today we're going to see problem number 1 in LeetCode. It is the two-sum problem, which is an easy problem. So given an array of integers, return indices of the two numbers such that they add up to a specific target. You may assume that each input would have exactly one solution and you may not use the same element twice. So which means they expect us to return the solution immediately as soon as we found it. Okay, and example is given nums equal to 2, 7, 11, 15, target equal to 9, and 2 and 7 add up to this particular number 9. So we have to just return their indices which are basically 0 and 1. See, the idea is very simple. We'll just use a hash map and basically put in the numbers and the corresponding indexes in the hash map. Okay, and so as soon as we encounter a number, so let's say 2, we encounter the number 2. So now there's nothing in the hash map, so we'll put 2 onto the hash map and we'll record its index. So its index will be the value. So what you'll do is you'll put 2, 0 in the hash map. And now when you see the number 7, what you do is you calculate the complement. And so basically complement means 9 minus the current number, right? So 9 minus 7 is 2, and 2 is a number which is already present in the hash map and its index is 0. So which means we have found two numbers which add up to the specific target, right? So intuitively also what you will do is you will see 2 and you will basically see which other number when added to 2 results in 9, and the number which when added to 2 results in 9 is 7, right? So that is how in any intuitive solution will work. We're basically expanding on the intuition. So basically to know which number has been saved and basically to see whether the complement is already present, we're using the hash map. So what you'll do is, so as soon as you see, so our example has 2, 7, 11 and 15. Okay, and if you consider the current complement, it is 9 minus 2, 7, and 7 is a number which is not present in the map. So what you will do is you'll put it in the hash map as 2, 0. Okay, and now 7, we are at number 7, and what you'll do is calculate the complement. And what is the complement? 9 minus 7, which is 2, and 2 is a number which is already present in the hash map at 0. So basically what you'll do is you'll get 0 and you'll get the current index which is 1 and return it as the answer. Okay, so what if our target is 18? Okay, let's say our target is 18. Okay, in this case let's start from the beginning. So we'll calculate the complement. So 18 minus 2 is 16. 16 is a number which is not present in the hash map, so we'll just put 2 and 0. Okay, 2 is the number and 0 is the index where it appears. And next we see the number 7 and we'll calculate the complement, which is 18 minus 7, which is 11, and 11 is a number which is not present in the hash map. So let's go ahead and record 7 and 1. And now let's see the other number, which is 11. Now let's calculate the complement. So 18 minus 11, this is 7, and 7 is a number which is present in the hash map. So now we have encountered a solution, which means 7 is the number and the current number is the other number, which when added together will result in the target. So let's get the previous complement's index, which is 1, and let's get the current index, which is 2, and basically we'll return 1, 2. I hope the approach is clear. So let's go ahead and program this. So let's have a hash map. Integer comma integer, we'll store the number and its corresponding index. We're going to call it as map, and we'll have hash map. let's initialize this. So this is integer, comma, integer. Okay, now for, let's iterate over the nums array. So for an int index equal to 0, index is less than nums dot length, okay, and index plus plus. So let's calculate the complement. So complement is nothing but target minus the current number, so nums of index. Okay, so let's check whether this complement is present in the hash map. So if it is present, then we are just, we have to just return it. So if you see, the output is in the form of an integer array. So let's get the complements index. So it will be already recorded in the map. So map.get of complement. So this will give us the previous numbers index, and then let's record the current index, which is index. Now in the event we do not find anything, let's return new int of 0. Okay, and what if we do not have it? In that case, we have to just go ahead and put it in the map, right? So map dot put the current number, so nums of index, comma, index. Okay, so as soon as you see for this example 2, 7, 11, 15, you see 2, and you calculate the complement. So target minus nums of index, so target is 9, so 9 minus 2 is 7, so 7 is a number which is not present in the map. So we'll go ahead and add nums of index, which is 2, comma 0, and we'll encounter 7, and 7 we'll take the complement of it, so which is 9 minus 7, it's 2. 2 is a number which is present in the map, so we'll return new int to return new int of map.get of complement. So complement is 2, so map.get of 2 will return 0, so and then the current index is 1, so we'll basically return 0, 1. Okay, let's quickly run this program. It's accepted, and it's a successful submission, and it beats 99.89% of Java online submissions for 2Sum. As you can see, we're using a hash map, right? So it's of n solution, and then we're iterating over the nums array and putting it, and as soon as we encounter this solution, we're returning it. So anyhow, at the worst case, you will have to iterate over until the end of the array. So in that case, the runtime complexity is going to be O of n. So both the space complexity and the time complexity is O of n for this problem. So that's it, guys. Please like it, and if you have any other requests to requests regarding videos, or specific requests regarding certain problems, please let me know in the comment section. Thank you so much. Bye.